Hello everyone, welcome to the Internship Studios session on AWS Cloud Automation. So, cloud automation plays a very important role while operating in the cloud because doing things via the console or the CLI is a very tedious process. So, in the modern times, human toil is actually very negligible. So, there are processes in place where the repetitive tasks are taken care of and will save a lot of time doing this automation stuff. So, for example, you cannot go every time on the console and spin up a EC2 instance every time doing the steps as we saw in our EC2 sessions. We enter the name manually and we did all those things like the OS configuration, the server configuration, the CPU, RAM, the subnet, VPC, networking settings, the tags. So always we use the mouse and via the console we did all the things. But it's okay for the beginners. But when you move your expertise with the cloud, what happens is there will be if you want to do the same thing 10 times. So there's a high possibility that one time you will do something wrong while typing or by selecting. So it's a human tendency for that error. But if via has code we do, like if you have some automation script, for example we have Terraform, so if we just write the code once correctly we can use it multiple times using the same code, so there is no possibility of any errors. So that's why nowadays there are many tools and this cloud automation is taking in demand very much nowadays. So we have for container based we have Kubernetes, for serverless offerings we have Lambda, for images creation we have the HashiCorp Packer, and for infrastructure we have this HashiCorp Terraform. So HashiCorp builds awesome DevOps tools. So Terraform is what we'll be doing a hands-on in this session. So coming to the introduction to automation in cloud computing. So automation in cloud computing, it refers to the use of software and tools to automatically manage and control various aspects of cloud infrastructure. So it enables organizations to streamline and optimize their cloud operations, reducing manual effort and increasing the efficiency. So automation in cloud computing plays a very crucial role in delivering scalable, reliable and cost-effective cloud services. So in the current times, business and organizations are increasingly turning to the cloud automation to enhance their operational efficiency, agility and overall competitiveness. So at the core of cloud automation, we have the concept of automating manual and repetitive tasks associated with provisioning, configuration, scaling, or management of the cloud infrastructure and services. So this automation not only accelerates the pace of deployment but also ensures consistency, accuracy, and reliability across various components of the IT environment. So, as organizations today grapple with the complexity of managing diverse and dynamic workloads, cloud automation becomes instrumental in taming the intricacies and ensuring seamless operations. So, one of the primary advantages of cloud automation lies in the ability to optimize resource utilization. So, through automated provisioning and scaling, organizations can dynamically allocate computing resources based on demand, so thereby preventing over provisioning and reducing unnecessary expenses. So this elasticity ensures that businesses can scale their infrastructure up or down in response to fluctuating workloads, optimizing costs while maintaining performance and responsiveness. Moreover, cloud automation facilitates faster time to market for products and services. So traditional IT processes often involved manual intervention and lengthy approval cycles, so which was leading to delays in delivering appropriate solutions for customers. So with automation, these processes are now streamlined, enabling rapid development, testing, and deployment. So this agility is particularly crucial in today's fast-paced business environments, where being the first into market can make a significant difference in gaining a competitive edge. So as AWS came first in the cloud computing space, now you can see that it is holding around close to 35% market share. So being first to market always plays to advantage. And also the security and compliance are also very paramount concerns for organizations in the digital age. So cloud automation contributes to these aspects by enforcing consistent security policies and configurations across the entire infrastructure. Automated monitoring and response mechanisms can detect and address security threats in real time, reducing the risk of data breaches and ensuring compliance with industry regulations. So, this proactive approach enhances the overall security posture of organizations, instilling confidence among stakeholders and customers as well. Also, by cloud automation, what happens? Collaboration and innovation is also further increased. So, by automating routine tasks, the IT teams we have can redirect their focus towards strategic initiatives and creative problem solving. So, this shift from manual to strategic work not only boosts employee morale but also cultivates an environment where innovation thrives. So, with more time and resources dedicated to exploring new technologies and methodologies, organizations can stay at the forefront of industry trends and continually evolve to meet changing demands. Also, cost optimization is another thing which is a central driver behind the adoption of cloud automation. So, by automating resource allocation, scaling, and deprovisioning, organizations can achieve significant cost savings. Additionally, the pay as you go model of cloud computing allows businesses to pay only for the resources they consume, eliminating the need for large upfront capital investments. So, this financial flexibility is especially advantageous for startups and small to medium sized enterprises, enabling them to compete with larger counterparts or a more level playing field. So, another aspect of cloud automation is its role in disaster recovery and business continuity. So, automated backup processes and the ability to replicate infrastructure across multiple geographic regions ensure that organizations can quickly recover from disruptions. So, the resilience provided by cloud automation minimizes the downtime, it safeguards data integrity also, and preserves the business continuity, even in the face of the unforeseen challenges such as natural disasters or cyber attacks. So, furthermore, cloud automation empowers organizations to adopt the modern DevOps culture. So, fostering collaboration between development and the operations teams. So, the integration of automated testing, continuous integration, and continuous deployment, which is CI/CD pipelines, accelerates the software development cycles and enhances the quality of deliverables. So, this seamless collaboration promotes innovation, agility, and the ability to respond rapidly to changing market demands. So, as we say, like cloud automation is a cornerstone of modern IT strategies nowadays. It provides a myriad of benefits that extend beyond mere operational efficiency. So, from cost optimization to security enhancements to fostering innovation and enabling rapid scalability, the impact of cloud automation is very profound. So, this was about a bit of introduction. So, next is benefits of automation in cloud computing. So, as we already discussed, it improves the operational efficiency. So, automation eliminates repetitive and time consuming tasks, allowing IT teams to focus on more strategic initiatives. So, next is the increased agility. So, automation enables rapid provisioning and scaling of resources, facilitating faster deployment of applications and services. So, with automation, what you can do quickly in a minutes, you can create a testing environment for developers to test their application. Next is the enhanced reliability. So, automated processes reduce the risk of human error and ensure consistent configuration and management. So, as we see, like humans, if we do 10 times the same thing, there's a possibility that somewhere or sometime due to our oversight, we can lose something. So, it's always possible that we have a set automated process, maybe some scripts or some process that keep in place so that the process are not deviating from the consistent configuration. So there are a couple of key components of automation in cloud computing. The first is the orchestration. So automation tools enable the coordination and management of various cloud resources such as virtual machines, storage, and networking to deliver seamless services. So orchestration begins with the definition of workflows, which are sequences of tasks or processes that need to be executed to achieve a specific goal. So cloud orchestration is often facilitated by dedicated automation tools and platforms. Popular choices include AWS Cloud Formation, which is native to AWS. We have the Azure Resource Manager, which is called as ARM from Microsoft Azure. Next, we have the Google Cloud Deployment Manager, which is from the Google Cloud Platform. And next, we have third-party tools like Terraform from HashiCorp. So these tools provide a way to codify the infrastructure and application configurations using declarative or imperative scripts, enabling the automation of provisioning and management tasks. So next is the configuration management. Automating configuration tasks ensure consistency and reduces the chances of misconfiguration across multiple cloud instances. So earlier like we had configuration management as a discipline within the field of IT management that focused on establishing and maintaining the consistency and integrity of an organization's hardware and software infrastructure. So it involved the systematic management of configuration items, which in short were called as CIs, which can include hardware components, software applications, documentation, network configurations, and other elements that make up an IT system. So the primary goal of configuration management is to ensure that the IT environment is well defined, controlled, and aligned with the organization's requirements. So key components of that also included CIs, which is configuration items. So examples included servers, routers, software application, maybe database, network configuration, or any documentation. So next we had something called as configuration management database. So the CMDB is a centralized repository that stored information about configuration items and the relationships. So it serves as a comprehensive and up-to-date source of information for the entire IT infrastructure. So next was the configuration baseline. So a configuration baseline was a snapshot of configuration items at a specific point in time. So it represented a stable and known state of the IT environment, serving as a reference for any future changes and comparisons. It also included version controls. So configuration management involved maintaining version control for software and configuration files. So this ensured that the changes can be tracked and previous versions can be restored if needed. So next component we have is the provisioning and scaling here. So automation simplifies the process of provisioning new resources and scaling them up or down based on demand, optimizing resource utilization. So you'll be using only whatever the required resources for that particular cloud infrastructure operation. So it also enhances the lean way of working, means keeping processes simple and up to the mark. So we have a couple of uh, automation frameworks in cloud computing. First thing is infrastructure as code. So using tools like Terraform or AWS Cloud Formation, ISE enables the automated provisioning and management of infrastructure resources through code. So ISE, which is short for infrastructure as code, it is a revolutionary approach in the world of IT. So it has nowadays transformed the way we manage and deploy infrastructure. So at its core, ISE involves treating infrastructure. So the backend infrastructure in cloud is just nothing but servers, networks, and other components has code. So this means that instead of configuring and managing infrastructure manually, you express your desired infrastructure state in a script or a set of files. So this script can be versioned, tested and automated, providing a more efficient, reliable and scalable way of handling the infrastructure. So the traditional method of setting up and managing infrastructure involved a manual and time consuming process. So the IT professionals would configure servers, install software and handle various aspects of the infrastructure manually. So this approach was not only labor intensive but it was also prone to the human errors. So additionally it often lacked the consistency across different environments, leading to deployment issues and inefficiencies. So with ISA what happened? The process of managing infrastructure is similar to software development. So infrastructure configurations are written in a script using a language that is easily understandable and editable. So this script is then executed to automatically provision and configure the desired infrastructure. So there are some key components for this. So there were like we have a declarative versus imperative approach. So ISC can be either declarative or imperative. So declarative ISC describes the desired end state and the system determines how to achieve it. Imperative ISC specifies the exact steps to take to reach the desired state. So declarative ISC is often preferred for its simplicity and abstraction. So also this ISC framework is implemented through something called scripts or templates written in languages like YAML. So we have a YAML language, we have a JSON language or specific domain specific languages which are like HCL for HashiCorp Terraform. So these scripts, what they do, they define the configuration, relationships and dependencies of infrastructure components. So also it benefits from version control systems like Git. We have Git has version control where we store the code. So infrastructure code can be versioned, enabling teams to track changes, roll back to previous states and collaborate effectively. So this version control ensures that the platform is very consistent and is traceable. Also ISU what it does, it encourages the creation of modular and reusable code. So the infrastructure components can be defined as modules and these modules can be reused across different projects or environments. So this promotes consistency and reduces duplication of effort. So there are some benefits of ISE also. One is consistency. So ISE ensure that infrastructure is consistent across different environments. So whether it's development, testing or production, the same code can be used to provision and configure infrastructure, reducing the likelihood of discrepancies and errors. Also automation here is the cornerstone of ISE. So tasks that used to take hours or days can now be executed within minutes or even seconds. So this speed and efficiency are crucial in today's fast-paced development and deployment life cycles. So ISA also enables easy scaling of the infrastructure as well. So whether you need to deploy one server or 100, you can adjust the parameters in your code and let the automation tools handle the scaling process automatically. So infrastructure can also be easily modified or extended by updating the code. So this flexibility allows for quick adaptation to changing requirements, making it easier to experiment, iterate and innovate. Also version control and modular code make collaboration smoother. So teams can work on different parts of the infrastructure simultaneously, knowing that changes can be integrated very seamlessly. So this collaborative approach is very essential in modern development practices. So next is the traceability. With version control, you have a detailed history of changes made to your infrastructure. So this traceability is invaluable for troubleshooting, auditing, and understanding the evolution of your system over time. So ISA also simplifies the disaster recovery processes. So in case of a failure or the need to recreate an environment, you can rely on the code to reproduce the infrastructure quickly and consistently. Also ISC contributes to cost optimization by allowing you to provision resources on demand and deprovision them when they are in no longer needed. So this aligns with the pay-as-you-go model of cloud computing. So to see IAC in action, imagine like you are a developer tasked with deploying a web application. So with IAC, what you do first? You first define the infrastructure. So you write code to define the infrastructure, specifying the number of servers, the network configuration, and any required services. Next, what you'll do is you version and collaborate. So you store this code in a version control system like Git. So Git systems we have, like you may have heard of Microsoft's GitHub or Atlassian's Bitbucket. So these are some popular source code repositories. So here your team members can collaborate, make changes, and propose improvements through version control branches. So next is we'll automate the deployment. So now you use an ISA tool like Terraform to automatically deploy the defined infrastructure. So this tool communicates with the cloud provider's API to create the necessary resources. So if your application experiences increased traffic, you update the code to increase the number of servers. So the IAC tool takes care of provisioning additional resources, ensuring scalability. So over time, as your application evolves, you make changes to the infrastructure code to reflect new requirements or optimizations. So the version control system keeps track of these changes, providing a history of the infrastructure's evolution. So next comes the DevOps automation. So leveraging tools like Jenkins or Ansible, DevOps practices automate the deployment and management of applications in the cloud environment. So Jenkins and Ansible are CI/CD tools. So Jenkins helps in continuous integration and continuous deployment, and Ansible works as a IAC tool. So it was born out of the on-premise environment in the early 2010. So it's also a very capable tool to mostly system admins used this for on-premise environments or data center operations. So next comes the service orchestration. So tools like Kubernetes or AWS Elastic Beanstalk automate the deployment and scaling of containerized applications, simplifying the application management. So we have Kubernetes, which comes with container orchestration capabilities. So in AWS we call it as EKS, which is the Elastic Kubernetes Service, which is the managed service. So it helps in deploying of our container based application. So you can see there is a sea of tools here. Uh, don't be overwhelmed by seeing this actually, because CNCF is a great organization actually. It's a platform which promotes open source adoption, open source application adoption. So they already have most of the projects that help in these DevOps tools. So you can check CNCF. You can just type in Google, which is the Cloud Native Computing Foundation. So they have a set of tools. So they mainly foster cloud native application development and software development. So we have, like, for collaboration tools, we have the application lifecycle management, we have the Jira tools, we have the Visual Studio, we have the Trello app. For communication and chat ops, which is chat operations, we have the Slack, where teams can efficiently communicate their day-to-day work with them. Next, we have the HipChat, we have the Microsoft Teams. So under knowledge sharing, we have the GitHub pages, we have the Confluence, which is a tool by Atlassian. If you do any documentation work, then it's very useful for that. And we also have Reddit Open API. But under build, where you can play around with the source code and its storage, we have something called Git. So Git is like a version control system. So related to Git, we have GitHub, which is a platform by Microsoft. These are licensed versions. These are actually free for only personal use. If you want to use them enterprise versions, then you have to pay a certain amount. They have various plans. So we have Atlas and Bitbucket, which is a source code management tool. again from Atlassian. We have a GitLab. So GitLab is also a very famous tool nowadays. We have the concept of runners with them. If you want to explore that, you can just explore. So under next continuous integration, CI means continuous integration. So here we have the TeamCity. So the modern most in-demand tools nowadays are TeamCity, Jenkins. So this is also open source. We have the Bamboo, which is the Atlassian product. Next we have the Travis CI, Circle CI, and CodeShip. So again under build tools for Java based applications, we have the Maven tool, we have the Gradle tool. Also we have Docker for packaging the application. We have the HashiCorp Packer as well here. So which is a product from HashiCorp to automate the creation of machine images. So under database management, we have Flocker, DB Deploy, DB Maestro. For testing, if you have heard of QA roles, so if you have come, like if you go to LinkedIn, which is a job searching platform, and type QA, so QA engineers are quality assurance engineers, which use this test automation tool, which is called Selenium. So we also have more like OS, Zap, we have Jasmine, we have Karma, we have JUnit, QUnit, Cucumber, JMeter, BlazeMeter, PyTest, Server Spec, Browser Sync. So these are popular testing tools. Next comes the deploy. So after the application is built and tested, so it's time to deploy. So we'll test the deployment of application using Octopus deploy, Excel deploy. We have other tools called as Spinnaker, and next we have the configuration management or provisioning. So once the application ready, you need to help that application run under the infrastructure. So we have tools like Puppet, we have Chef. So these were old legacy tools, but nowadays in-demand tools are Terraform and Ansible. So mostly if you go to job descriptions nowadays, they ask mostly Ansible and Terraform for the infrastructure as code. So next is the artifact management. So we have Docker Hub, we have the Docker registry. So we have JFrog Artifactory to store all your artifacts. We say them as build artifacts usually. So next, after you have deployed the application, you have to deploy it somewhere, right? The backend where you will run that application. You need some big platform with infrastructure capabilities. So there comes the cloud IaaS PaaS models. So we have the Amazon Web Services, we have the Google Cloud Platform, we have the Microsoft Azure, we have Rackspace, we have OpenStack, we have AppFrog, OpenShift. These all are individual vendors who offer these services. Then we have the orchestration and scheduling. So we need to orchestrate the deployment that we have done. So that can be achieved through Kubernetes. So Kubernetes will orchestrate container based workloads. We have the Nomad from HashiCorp, which is also offering from their side. We have the Rancher, we have the Docker Swarm, we have the Mesos. So next, after we are while orchestrating, we need to see how the application is performing, whether it is healthy. So we need to have some monitoring setups as well while we run the application. So there we have these tens of different types of monitoring. So famous ones nowadays include Elasticsearch, Splunk, we have Kibana, Datadog, App Dynamics, we have Sentry, New Relic, Prometheus, and Dynatrace is also familiar. So Sensu is there. So we have PagerDuty. But nowadays most in demand is the Prometheus and the Grafana combination. So next important thing is security and compliance automation in cloud computing. So automation can enforce security policies and configurations consistently across cloud environments, reducing the risk of security breaches. So compliance monitoring and reporting. Automation tools can continuously monitor cloud resources for compliance with regulatory requirements, generating reports for auditing purposes. Next is the incident response automation. So automated incident response workflows enable rapid detection and remediation of security incidents, minimizing the impact on the cloud infrastructure. So incident response, we have the PagerDuty. So it has the capability to be incorporated with Slack communication tool. So once there is some incident that has happened, you can get the alerts, and then and there itself you can acknowledge the alerts and get to know and start working on it. Next is challenges in implementing automation in cloud computing. So first is the complexity. So cloud environments can be complex with multiple services and components that require very careful orchestration and configuration. So mostly uh, people who come to the cloud always use this microservices approach. Microservices as we discussed in earlier sessions, nothing but what we can say, these are some individual modular components of the application. So when we have a server side multi-tier architecture applications, we have the server side, we have the database side, we have the storage side, and the network side. So these environments will be very complex such that there are very multiple services, so we need to have different teams for different services. You need to have a specialty network team, a specialty database team, a specialty server side team, and specialty storage related teams so that they can handle with utmost precision. So next is the skill set gaps. Implementing automation in cloud computing requires expertise in both cloud technologies and automation tools, which may not be readily available. So what is happening nowadays? You see that every tool is coming nowadays. Like new tools are being launched by CNCF. Innovation is happening at a rapid pace. We have the era of Chat GPT, where AI ops has come up, and everything is become AI related. So they have become very robust in their capabilities. So humans are actually lagging behind. They need to adapt to the latest skill sets that the market is offering. Since cloud itself is a very big vast area to be an expert, because AWS also releases n number of tools almost every day. So each thing comes up every day and some features will be released. So you have to be up to date with the cloud technologies, and also automation tools means Terraform, Kubernetes, Ansible. You need to be sound in these updates also. But these are actually not readily available. As a human, it's very difficult that you'll be a master in everything. But as and when experience grows, then people will slowly gather the expertise. So this is one of the challenges today in implementing automation, which is a skill set gap. Next is the resistance to change. Organizations may face resistance from employees who are accustomed to manual processes and adapt to the new automated workflows. So we have many legacy companies who are stuck in the same old processes. Their employees are also doing the repetitive work. But what happens if something new comes up and it's mandated to shift to that new technology? So employees may resist that we are not knowing this technology and we can't update it. So there they can't fire the employees also, because they are holding the processes, so they know the old processes. So also it's also difficult to migrate that. So there's a bit of resistance to change as well. So we'll see the best practice for automation in cloud computing. So first is start small. So begin by automating simple, repetitive tasks and gradually expand automation to more complex processes. First, what we need to know, we need to know how to spin up a EC2 instance in AWS code. Then we can go ahead and spin up a S3 bucket, the database AWS RDS. We can go to spin up AWS VPC. So we have to start with something small at our hands to understand the concepts at first. Next is collaborating across teams. So it involves IT operations, development, and security teams to ensure a holistic approach to automation and gain buy-in from stakeholders. So pre-sales teams, we have something called pre-sales teams nowadays in cloud organizations. So they need to be well aware as well. So they are the ones who are facing the customers and pitching the products. So collaboration has become a very important part nowadays for cloud as well, because you need to understand the customer requirements clearly first, because if there is some miscommunication happening when you go live stage of the application, then things go haywire and there will be unnecessary complexities. So it's always better that You keep on collaboration daily using some meetings or any Slack chat ops. Next is the continuous improvement. We need to regularly review and optimize automated processes to identify areas for improvement and ensure they align with evolving business needs. So we need to see like KPIs, which is the key performance indicators for each existing setup we have, and then we can continuously improve based on gradual changes. So coming to this Netflix automation journey, Netflix has embraced automation in its cloud infrastructure to deliver its streaming services reliably and at scale. So they use tools like Chaos Monkey to automate the injection of failures in their systems, allowing them to identify and fix weaknesses proactively. So automation enables Netflix to rapidly deploy updates and improvements, ensuring a seamless user experience while reducing downtime. So you can see the beauty of wording here. So Chaos Monkey means a mad monkey. So what it will do if you leave it in the house? So it will throw around the items inside the house and create the disturbance. So similarly, they have a tool called internal tool called Chaos Monkey. What it will do will just increase the resources in their Kubernetes clusters, and it will just uh, do a network outage or just increase a DDoS attack. So this helps the Netflix DevOps or site reliability engineering teams to understand the situation and respond accordingly. So by this they can, in real world, what happens when in case if something goes wrong in the cloud, then using this knowledge and automation they can revert and fix that back. So next case study is the Amazon Web Services automation capabilities. So AWS provides a wide range of automation capabilities through services like AWS Cloud Formation, AWS Lambda, and AWS Step Functions. So these services allow users to define and automate the creation, deployment, and management of AWS resources through code or visual workflows. So AWS automation tools enable customers to achieve scalability, agility, and cost efficiency in their cloud deployments. So step functions you may have heard for the first time. So it's a service by AWS that enables you to coordinate and orchestrate multiple AWS services into serverless workflows. So with step functions, you can design and run workflows that integrate different AWS services, control flow, handle errors, and manage the execution sequence of tasks in a scalable and efficient manner. So it allows you to visualize, manage, and scale the complex workflows, making it easier to develop and maintain distributed applications. And it has couple of good use cases as well. So it is mostly used in the business process automations, in data processing pipelines, in microservices orchestration, in application integration, and AI/ML workloads. So next is the future trends what we have in automation for cloud computing. So these are not the future trends actually, these are actually happening right now. So first is the artificial intelligence and machine learning. So AI and ML technologies are being incorporated into automation tools to enable intelligent decision making and self-healing capabilities. Next we have the serverless computing. So serverless architectures abstract away infrastructure management, allowing developers to focus solely on application logic, further simplifying automation. Next we have the edge computing. So automation will extend beyond the cloud to edge devices, enabling real-time decision making and reducing latency for critical applications. So edge computing refers to the practice of processing data near the source of generation rather than relying on a centralized cloud or data center. So this decentralized approach brings computing resources closer to where data is produced, reducing latency, improving response times, and conserving bandwidth. So edge computing is particularly valuable in scenarios where real-time processing and low latency interactions are essential, such as in the Internet of Things, deployments, smart cities, and industrial automation. So edge computing brings computing resources closer to the data source, which could be IoT devices, sensors, or other endpoints. So by processing data locally, what happens is edge computing minimizes the time it takes for data to travel from the source to a centralized data center and back, resulting in lower latency. So next is the distributed architecture. So edge computing involves a distributed architecture where computing resources are strategically placed at the edge of the network, forming a network of edge nodes. Also, edge devices can perform data filtering and pre-processing before sending relevant information to central systems. So this reduces the volume of data transmitted and optimizes bandwidth usage. So real-time processing capabilities at the edge also enable immediate responses to events, which is critical in applications like autonomous vehicles or industrial automation. Also, we have AI Ops, which is an approach that leverages artificial intelligence and machine learning to enhance and automate various aspects of IT operations. So, AI Ops actually aim to improve the efficiency, scalability, and reliability of IT systems by using advanced analytics and automation to detect and resolve issues. So, like in conclusion, we can say automation in cloud computing is very essential for organizations to maximize benefits of cloud services and optimize the resource utilization. So it enables the faster deployment, improved operational efficiency, enhanced reliability, and better security and compliance. So by embracing automation, businesses can stay competitive, innovate faster, and deliver high quality services in the dynamic cloud computing landscape. So firstly, as part of this cloud automation in AWS, we'll go ahead and discuss AWS Cloud Formation. So AWS Cloud Formation is the backbone of the automation space of AWS. So it integrates with almost every service of AWS. So maybe it is the Amazon API Gateway, the Amazon RDS, S3, VPC, Code Pipeline, SNS, EC2, DynamoDB. So it acts like a single point of strength for all of those. So we'll have an introduction of it first. So AWS CloudFormation is a service that allows you to model and provision AWS resources. It enables automate it helps automate the creation and management of infrastructure in a repeatable and predictable way. Means you can repeat the process using a single configuration many times, and predictable way means you can predict like what's going to be provisioned. So if I write a EC2 instance code in CloudFormation using the JSON format, you already know that an EC2 instance is getting provisioned in the console. So next is CloudFormation templates are written in YAML or JSON and describe the desired resources and their configuration. So YAML is short for yet another markup language. So it's a simple human readable format. And JSON is short for JavaScript object notation. So these are actually you can say the DSLs of the cloud. So these are very popular. So YAML you can see if you are write manifest templates, for example in Kubernetes, they are based off YAML. JSON is actually for this HashiCorp HCL. It is based out of JSON syntax. So actually CloudFormation supports both these syntaxes we can say. Next is we'll see the benefits of AWS CloudFormation. First thing is IAC. So it enables version control, collaboration, and reproducibility. So version control means you can store the code in the GitHub and make multiple versions out of it. Collaboration, so since it's already hosted on the Git repos, so multiple teams can fetch the code from those repos and work on it independently. And reproducibility means it helps in producing multiple instances of the same version. Next is CloudFormation provides a consistent and reliable way to manage and update the resources. So since it's based out of code, so it's very like it provides a very consistent infrastructure in the cloud environment. And also since it acts as a single source of truth. You know, like who made what changes to what section of the code. Next is it simplifies the provisioning process and reduces manual errors. Since it's a code based tool, so there is no manual entry here unless you are writing the code itself as wrong. So there will not be a question of wrong provisioning here. Next is the cloud formation stack. So here a stack is a collection of AWS resources that are created, updated, and are deleted together. So resources in a stack are defined by a cloud formation template. So stacks can be managed using the AWS Management Console, AWS CLI, or Cloud Formation APIs. So here there are a couple of operations with cloud formation stacks. So to create a stack, here you provide a cloud formation template and you specify configuration parameters and execute the create stack operation. So AWS Cloud Formation then provisions the specified resources based on the template. So again, if you need to modify your infrastructure, you can update an existing stack by providing an updated template or modifying the parameters. So CloudFormation will modify the stack to reflect the changes without recreating resources that haven't changed. So when you are done with a set of resources, again what you can do, you can delete the stack. So AWS CloudFormation will delete all the resources provisioned for that stack. This helps in efficient resource management and cleanup. So what you will do if a stack update fails? So CloudFormation can automatically roll back to the previous stack state to maintain the consistency and integrity of the infrastructure. So we also have the concept of nested stacks. So Formation supports nested stacks, allowing you to break down complex templates into modular and reusable components. So each nested stack is a separate CloudFormation stack with its own template. So next we have the CloudFormation template structure. So templates consists of sections like parameters, resources and outputs. So I'll show you in the next images how the code actually looks like. Next we have parameters that allow customization of the template at runtime. Next, resources define the AWS resources to be created such as EC2 instances or S3 buckets. So here it's a simple elastic beanstalk sample template. So which is a JSON type of infrastructure code we have. So you can see first we have the AWS template format version. So always we have the template format version at the top. Next we have the description. So this optional field, it's an optional, it's not actually required when you're provisioning. So it allows you to provide a human readable description of the cloud formation template, like for which purpose this is used for. So it serves as a documentation for the purpose and content of the template. So next we also have the metadata. So metadata is not present at this point, but if you see some other cloud formation templates you will. So this optional field also allows us to include additional information such as comments or annotations in the template. So metadata does not affect the AWS resources created. So next we have the parameters. So this section allows us to define input parameters for the template. So parameters provide a way to customize the template when creating or updating a stack. So users can provide values for these parameters during the stack creation. So next we can also have sometimes called mappings. So mappings enable us to create a lookup table within the cloud formation template. So we can use mappings to associate different values based on the conditions or criteria. So next we can have conditions also. So conditions allows us to control whether certain resources are created or whether certain properties are set based on parameter values or other conditions. So next is the resources section. So resources section is the heart of the cloud formation template. So it defines the AWS resources that will be created or modified when the stack is launched. So each resource has a logical ID and a type with it. Next we have the outputs. So output section can allow you to define the values that you want to be displayed or made available for reference after the stack is created. So these outputs can be used in other stacks or by users. Also we can have something called metadata, conditions and outputs. So that section combines metadata, conditions and outputs into a single convenient section for quick reference and easy maintenance. Also, if you see intrinsic functions, so intrinsic functions are used within the template to perform operations or retrieve information dynamically. Again, like they have the concept of parameters and resource references. So parameters and resource references are used to dynamically insert values into the template and create more reusable and customizable templates. So these are some of the fundamental components and concepts within an AWS CloudFormation template. So the flexibility of CloudFormation templates allows us to define complex infrastructure as code, and the templates can be version controlled, shared, and reused across different environments. Understanding structure and syntax of CloudFormation templates is essential for efficiently deploying and managing AWS resources in a programmatic and repeatable manner. So as we already saw, we have the template parameters. So parameters are used to customize the stack creation. So they can be defined with different data types, for example, string, arrays, uh, or boolean values, anything. So default values and allowed values. Parameters enable flexibility and reusability of the templates. Next, we have the template resources. So resources represent AWS infrastructure components. So each resource has a logical ID with it, type and properties. So properties define the specific configuration for the resource. So resource, for example, in terms of AWS, we can take it as an EC2 instance. So what does an EC2 instance will have? So it will be having its own ID, and then the properties it will have, like what is the RAM, what is the OS type, so how much GB of storage, any EBS volumes to be attached. So these come under the properties of it. Next we have the template outputs. So outputs provide information about the stack after it's created or updated. So when you provision the infrastructure using CloudFormation, we have something called as outputs. So they can be used to reference resource attributes or provide useful information to users about the created infrastructure. Outputs can be exported and shared across stacks. So one template output can be referenced to a different template output. Next is the CloudFormation stack operations. So first is create a new stack based on the template and specified parameters. Next we have the update. So it applies change to an existing stack based on template modifications. So delete means it will delete the entire stack and its associated resources. Resources means any associated infrastructure resources, we can say, under AWS. Also we have some stack policies. So these stack policies allow fine-grained control over updates to stack resources. So policies can prevent updates to specific resources or properties. They help maintain the integrity and security of the infrastructure. Next we have the nested stacks. Nested stacks allows us to create modular and reusable templates. A nested stack is a stack that's included as a resource in another stack. They enable more complex architectures and simplified management. So stack policies are usually written in JSON format and are associated with a specific CloudFormation tag. And also they operate at the resource level, so specifying which update actions are allowed or denied for each resource. So it has couple of points, like it has effect policy, it has action policy, we have the principal, we have the resource and the condition. So optionally conditions can be set based on additional criteria like IP address. So nested stack, actually it's a feature in CloudFormation that allows us to use a CloudFormation template has a resource within another CloudFormation template. So modularity is a key feature of this. So it promotes modularity and reusability by allowing us to create separate templates for different parts of the infrastructure. Next we can do the template inclusion. So a parent template includes a nested stack as a resource, and the nested stack has its own template. So next is the parameter passing. Parameters can be passed from the parent stack to the nested stack, allowing customization. Also the nested stack can have outputs here, and the parent stack can use these outputs. So each nested stack also has its own set of resources, and updates to one stack doesn't affect the others. So example use case can be like the parent stack can be a application infrastructure. Then we can have the nested stack one which hosts the database. Then we can have the nested stack 2 which can have the load balancer. So what it will do is it allows creating or updating database and load balancer independently. So in simple terms you can see stack policies control what changes can be made to resources in a cloud formation stack, acting like a set of rules. On the other hand, nested stacks let you organize your infrastructure in a modular way by breaking it down into separate templates, which can be reused across different parts of application or even different applications. So next we have the CloudFormation rollbacks. So CloudFormation supports automatic rollback on stack creation or update failure. So rollbacks help prevent partial updates and ensure stack consistency. Rollback behavior can be customized using stack policies. So if something goes wrong, we have the provision of getting back to the original infrastructure. So this is means rolling back, which means coming back to the previous condition. Next we have the drift detection. So drift detection compares the stack's actual configuration with its expected configuration. So it identifies any changes made outside of CloudFormation. So drift detection helps maintain control and visibility over your infrastructure. For example, if you are working your way through the code and someone goes to the AWS console and modifies something using their hands. So Terraform will get to know that something has been changed and it always let us know while doing a Terraform, for example, this cloud formation operations. It will not drift away means it will not deviate away from the actual configuration or provision infrastructure, you can say. Next is the CloudFormation Designer. So it's a visual tool for creating, viewing and modifying the templates. So it provides a graphical representation of the templates, resources and relationships. So designers help visualize and understand complex templates. For example, if you are uh, having a very big infrastructure setup and you don't know like the relationship with each one, so how the each tool or resource is interacting with each other, so this designer will play a visual role here and it will help you understand the intricacies of each resource. So next is the cloud formation best practices. So we can use version control for templates and track changes over time. So we need to use the version control options available for us. It may be either cloud source repositories hosted in the cloud. We have the AWS code commit for it, which is native Git repositories in AWS, or you can use enterprise applications like GitHub or Atlas and Bitbucket for version controlling. So this helps actually to maintain a single source of truth over your code repositories. Next we have the test templates. So test templates using change sets before applying them to production. So you need to test your created template in a local or a test environment so that you can always revert back if something goes wrong and made the modifications accordingly. Also, we can leverage the AWS CloudFormation guardrails to enforce security and compliance. So, in the context of AWS CloudFormation, the term guardrails refers to the set of practices, policies, and mechanisms put in place to enforce certain constraints or guidelines during the deployment and management of AWS resources using the cloud formation. So guardrails are essentially a way to establish controls to prevent or detect non-compliant configurations and ensure that cloud formation stacks adhere to organizational standards. So these can be guardrails can be for example the stack policies as well. So stack policies can serve as a guardrail by allowing you to control updates to cloud formation. So stacks at the resource level. So stack policies are JSON documents that specify which update actions are allowed or denied for each resource in the stack. So this helps prevent unintended modifications to critical resources and ensures that changes follow a predefined set of rules. Next, AWS organizations can allow you to use service control policies as well. So to get guardrails at the AWS organization level. So SCPs act as a permission guards and can be used to control what services and actions can be used within an organization. So by implementing SCPs, you can restrict the cloud formation actions that are allowed across cross accounts within your organization. So we also have the concept of stack sets. So stack sets provide a way to manage cloud formation stacks across multiple accounts and regions. So guardrails can be established by defining what regions are allowed or restricted, and by specifying which accounts can participate in stack sets deployments. So this ensures a centralized and controlled deployment of stacks across an organization. So also we can leverage the AWS CloudTrail logs. So they can provide a detailed logs of CloudFormation API calls, allowing us to monitor and audit stack changes. By setting up CloudTrail with appropriate logging and alerting, you can establish the guardrails for detecting and responding to unauthorized or non-compliant actions. So in summary, we can say AWS CloudFormation guardrails are a combination of policies, permissions, and practices designed to control, monitor, and enforce compliance with organizational standards during the deployment and management of infrastructure using CloudFormation. So these guardrails help organizations maintain a secure, compliant, and well-governed cloud environment. So CloudFormation versus other tools. So we already know CloudFormation is AWS specific and tightly integrated with other AWS services. So it cannot be used with Microsoft Azure or Google Cloud. So it's only native to AWS, and only AWS services can interact with its APIs. So other tools like Terraform are multi-cloud and support a wider range of providers. So HashiCorp Terraform is the number one IAC tool in the market currently because it operates with multiple cloud providers. So it is not single cloud provider compliant. So the HashiCorp company has designed in such a way that it supports around I think 100 more than 100 providers at this point of time. So it can interact with Kubernetes, Ansible, any type of plugins. So yeah, it is the number one in the competition now. Next is the choice between tools depends on specific requirements and preferences. So if you are going to stuck and make your workloads only specific to AWS, then you can leverage the full functionality of the cloud formation. But if you have plans for any cloud migrations and new cloud adoptions in the future, then you should go with the HashiCorp Terraform. So coming to the limitations, it says some AWS resources and features are not yet supported by CloudFormation. So new resources which are getting launched by AWS, for example, in the last week or so, they take some time to be integrated into the CloudFormation stack. And again, updates to certain resources may require stack replacement instead of in-place updates. So for updating, like if you have created the infrastructure and that is around 2 years old, so if any new feature comes up, so incorporating that into CloudFormation becomes a bit of a difficult task, and you need to work from scratch itself. Next is the template size and complexity. It can impact deployment times and performance. So if you are writing a code that is very huge, so then the provisioning time and complexity can get higher, and someone who is very expert in knowing the relationship between all the resources, only they can actually get to know the flow actually. Next is CloudFormation pricing. So there are no additional charges for using CloudFormation itself. So you only pay for the AWS resources created by the stacks. Means the code level and whatever the backend operations it's doing with the resources, you need not pay anything. Just what the resources you are creating because of it, only that you need to pay. Be aware of any additional costs associated with the resources provision. So whenever you write the code, know that that resource how much is the pricing model for that, and provision accordingly. So here we'll see HashiCorp Terraform, which is the multi-cloud IAC tool. So this is the official logo of the Terraform. So we'll have an introduction first. So HashiCorp Terraform is an open source infrastructure as code tool. It provides a declarative language to define and manage infrastructure resources. Terraform allows users to define infrastructure in a version controlled and collaborative manner. It was an open source infrastructure tool. Now actually it is working on the license version. So HashiCorp have announced that Terraform is no longer will be open source and their source code will not be available. This is a very bad move actually. Earlier it was open source, so there was more community engagement and community contribution happening. But nowadays it has been opposed by the open source community in the tech world. So I think in the recent past actually, in around 5 months ago, I think they actually removed the open source tag it had. So currently what they are doing, they have forked the repo of the Terraform and they're just working out some newer tools around it like OpenTofu or something like that. So but still it's applicable for practicing for individual level, so you can just play around with the technology. So it provides a declarative language, means you will declare at first what you are going to define, like you have a set of templates from the Terraform registry and you will define what resource you are going to create. Also it helps users to define infrastructure in a version controlled and collaborative manner. So similarly you can use this as code and collaborate via the Git repositories, maybe GitHub or Bitbucket. So next is the key features. First thing is infrastructure as code. So here also we use something called as HCL, which is the HashiCorp configuration language, which is a JSON based language. Next we have the multi-cloud support. So it supports major cloud providers like AWS, Azure, Google Cloud and more. Also we have a resource graph. So Terraform builds a dependency graph to determine the order of resource creation and updates, because for example for EC2 to be created you need a VPC, and after that you will create a subnet, and then the firewall rules, the security groups, then EC2 instance. So Terraform in the code also, while provisioning, it will follow the steps like when which resources dependent on which. So subnets is dependent on the VPC. So it will create the VPCs first. So this is a very good feature of Terraform, we can say. So next is the benefits of using Terraform. First thing is the infrastructure consistency. So Terraform ensures that your infrastructure is consistent across environments. Maybe it is you are provisioning for AWS or Azure or Google Cloud. So whatever the infrastructure you have created, it will be consistent. Maybe if you are stuck in a single cloud and you are operating three environments, for example QA, staging and testing. So there also you can see that the infrastructure will be consistent if you use the same modules. Next is the scalability. It allows us to easily scale the infrastructure resources up or down as needed. So it also supports the scalability feature. Depending on the number of resources, we can do accordingly. So automation. Terraform automates the provisioning and management of infrastructure resources. Since it's ISC tool, so it fosters faster provisioning, so thereby fostering the automation process. Next, we need to understand the Terraform configuration language. So HCL is a very simple and expressive language used to define infrastructure resources. It allows us to create reusable modules and templates for infrastructure provisioning. HCL supports variables, conditionals, loops, and other features to make infrastructure configuration flexible. So it's like a JSON based language. We'll see in the hands-on session how it will look. So it also supports variables, conditions, loops. So if you are familiar with OOPS concepts, then you can also use it like for each loop. Similar fashion we can use the code. So we need to understand the workflow as well. We have something called as initialize, plan and apply. So these commands, what we do, will first use the terraform init command to initialize the terraform working directory. So terraform will create a working directory under which we can work with the code and all related operations. Next we'll run, after init we'll run the terraform plan. Then it will create an execution plan. It will say like what the infrastructure is going to be provisioned beforehand. so that we'll know what is going to be done after that. So after we'll execute Terraform apply, it will apply the changes and provision resources. So if we hit the apply, then our resources will be reflected in the AWS console. So we have the concept of providers. So providers are plugins, so that define and interact with specific infrastructure resources. So Terraform has a wide range of providers for various cloud platforms as well as on-premise infrastructure. So providers allow you to manage resources like virtual machines, databases, networks, and more. So we have something called a provider section in Terraform. So it will interact with for example, AWS. If you write the provider brackets AWS, then it will download the AWS plugin. Then you can go ahead and create the resources in AWS. So similarly, it has support for Google Cloud, VMware, Microsoft Azure, for Kubernetes, even for Crossplane it has, for Jenkins it has providers. So it has a wide variety of support, you can say. Next we have the concept of Terraform modules. So modules are nothing but reusable configurations that encapsulate infrastructure resources. So they enable code reuse, simplify infrastructure management, and promote best practices. Modules can be shared and used across different projects or teams. Modules means you write a generic code without hard coding any value. So then afterwards you can change based on the resource requirements and the configuration you want. So it helps us. There is also concept called something as parent model and child model. So we'll create the parent model and afterwards we need to play around with the child model. Next is Terraform and other configuration management tools. So configuration management tools like Ansible, Chef and Puppet can be used alongside Terraform. So Terraform focuses on provisioning infrastructure resources while configuration management tools handle software and system configurations. Combining these tools allows for comprehensive infrastructure provisioning and management solution. So we have other tools in the market. Ansible actually it was born from the on-premises world. So it supports most data center operations and cloud as well. Chef and Puppet are also legacy tools. They can also be used along with Terraform if your workloads need to be associated with these tools. So this is the simple Terraform snippet. So first is the Terraform uh, word we have here. Next is the required providers. So here in case we are using AWS, so it is important that we use the AWS provider. So source we have the HashiCorp slash AWS. The version is the HashiCorp provider version for that respective provider. Again we need to do the provider AWS so that it will go ahead and create inside the AWS environment. Region is very important so that our resources get created into that region. Next is the access key and the secret key. It is also very important to so that our Terraform can go ahead and enter into the environment. Next is the resource accordingly. So this is for the AWS instance which is the my EC2. So accordingly AMIs and instance type can be given. So next is the Terraform best practices. So we can use version control to track and manage infrastructure code changes. And next we can modularize configurations to promote reusability and maintainability. Next we can use remote state storage for collaboration and to ensure consistent state management. So remote state storage means we can store the state in the AWS buckets so that nothing, if you are working in a multi-team environment where multiple teams are working on the same Terraform code, so there should not be any state corruption. So that's why we can use the remote state storage. So thank you for the theoretical session here. So we'll go ahead and do the hands-on session now. So what I've done is we'll do spin up an EC2 instance using the AWS Cloud Shell here. So we have just installed the AWS Terraform, HashiCorp Terraform in the AWS Cloud Shell. So these are some steps that we need to do. So first we'll do the git clone. So I have taken from the open source TF utils repository. And what I'll do is I just create move to the, so next we need to do the tfn install 1.25 2.5, and then what we need to do, we need to use the tfnv 1.2.5, so it will install the 1.2.5 version. Then if we do the Terraform version, it will do Terraform v 1.2.5 on Linux AMD 64. Since the latest version is 1.7.0, so it's okay to just spin up an EC2 instance for now. So I'll just create a main.tf for now for Terraform. So first is the access key and secret key that we need to give. So this is a EC2 instance code that we have taken from Terraform registry. First thing component is the Terraform providers. So we need to provide the Terraform provider. So required providers is AWS. The source will come from HashiCorp/AWS. Next, the provider again, we have the component of AWS here. So the region must be specified where it is going to be deployed. Next, we need, it's compulsory to add the access key and secret keys here. And next is the resource block, which has a AWS instance. Since in this case we are going to create an EC2 instance, so I'll give on the name as my instance. Next, the EMI ID should be provided, which will be according to the OS that you select. So I have taken a Amazon Linux based EMI. So the instance type also should be specified here. Here in our case is the t2.micro instance. So if I do ls, you can see the main.tf here. So main.tf is the main file in the Terraform where you will write all the resource configuration here. So before I go ahead and provision an EC2 instance, so let's first check whether this EC2 instance exists under the instances dashboard. So I am in the console now. So I'll go to EC2. So we can see the instances running is 0 here. So there are no instances provision now. So we'll go back to here. So the first command that I will run is terraform init. We need to initialize Terraform first. It says initializing the backend. It says initializing provider plugins. So successfully, it says Terraform has been successfully initialized. So it says you may now begin working with Terraform. Now it says try running Terraform plan to see any changes that are required for our infrastructure. So we'll go ahead and run Terraform plan now. This is the next command. So yeah, this is the beauty of Terraform. See, just we have mentioned the EC2, but what all it is going to create here? It says Terraform will perform the following actions. The first is AWS resource and We have given AWS instance. My instance is the name, but you can see I have only given the AMI. But what are all the related things it is going to create? It will generate the ARN, the associated public IP address, availability zone, CPU core count. Everything will be known after the apply because still we haven't created the infrastructure, right? So public IP will also be known after creating the resource. Also VPC. So with along with that, EBS block device is also created, ephemeral block device, metadata, network interface is created, private DNS, root block device. So now what we do, so it says everything is known after apply. So it says in the plan one to add means one EC2 instance to add. So now I'll go ahead and hit the Terraform apply. So this is the third command. So it again throws a prompt says do you want to perform these actions. So Terraform will perform the actions described above. Only S will be accepted to approve. So only if you type S, then it will go ahead and provision. If you type no, then it will cancel the provisioning of infrastructure. So I'll go ahead and type S. So it says AWS instance. My instance is creating. So since I already saw in the dashboard, no instance had been created. So it says 10 seconds elapsed. So 10 seconds has been done. So it will let the user know how much time it is actually taking. So every 10 seconds it is giving a prompt of still creating. So yeah, apply is complete. So it says resources added 1. So we'll go to the dashboard now and I'll just hit go to instances running. So awesome then. So you can see the first instance running. Still it's in initialization state. So it's a T2 micro instance. So I'll go to the instance ID. This is the instance that we have created. So we have created the Amazon Linux based AMI ID is also similar. So this was about the hands-on session. Thanks for attending this session. So I'll go to the PPT block. So what we saw was we saw different options of automation available in the cloud, and we used Terraform as a hands-on session and used to create a EC2 instance. So in the next session we'll understand what AWS security services are and what is cloud governance and migration is. So thanks for attending the session and see you in the next session. Bye everyone.